Analysis of variance, popularly known as ANOVA, is a hypothesis testing technique used to test the equality of two or more population means. ANOVA allows you to determine whether the differences between the samples are simply due to random error or whether there are systematic treatment effects that cause the mean in one group to differ from the mean in another. For example, you are running retail outlets in 5 different locations, and you might want to know whether sales in those 5 locations are similar or not. In another context, your company introduced new performance pay and you are interested to assess employee satisfaction levels. One more example. You are planning to invest in equity shares and your friend suggested to invest in major bank stocks in USA. You wish to know whether net margins of major banks are similar or is there any difference. To get answers to these questions, you may compute ANOVA. Before computing ANOVA, you need to define null and alternative hypothesis. Major banks margins Excel workbook supplies net margins of top 10 major banks in USA for 10 years. You intended to know whether the mean returns of these banks are similar or different. To test this, you need to frame a null hypothesis and alternative hypothesis. Null hypothesis is there is no statistically significant difference in net margins of major banks. Alternative hypothesis is there is statistically significant difference in net margins of major banks. You wish to test your hypothesis at 5% significance level. To test the hypothesis, you need to compute one-way ANOVA. For that, click Data tab and select Data Analysis command. From Analysis Tools, select ANOVA Single Factor and click OK. Select Net Margins data along with banks names. In Group by, select Rows. This is your data is in rows. If data is column wise, then you need to select columns. Next, select label in first row. Next, as you want to test hypothesis at 5% significance level, set alpha as 0.05. In output options, choose New Worksheet. Click OK. ANOVA output is displayed in New Worksheet. Format the numeric values to number format with 2 decimals. This gives you better view of your data. Now we look at how to interpret ANOVA output. The ANOVA output has 2 sections. First section gives you the summary statistics. That is sum, average and variance values. You can see that the average net margins and variance of 10 banks, Citigroup, Bank of New York, State Street Bank report high variance. In ANOVA table, first look at p-value. P-value ranges from 0 to 1. To test hypothesis, compare calculated p-value with alpha or significance level. If p-value, that is power value, is greater than significance value, accept the null hypothesis. Else, reject null hypothesis. In this case, the p-value is 0.02, which is less than alpha, that is 0.05. So, you reject null hypothesis, which means the net margins of top 10 major banks are different. F value is calculated as between groups mean square value divided by within groups mean square value. And between groups mean square value is calculated as sum of squares of between divided by degrees of freedom between. Next, within groups mean square is calculated as sum of squares within divided by degrees of freedom within. Now, ANOVA explains you whether sample means are similar or different. It won't tell you the reasons behind it. You run the ANOVA test once again after removing major banks with high reported variance and observe the results. Compare this with the previous ANOVA test results. As you don't need to remember complex equations of ANOVA test, with Excel, you can experiment as many times as you wish by changing the sample size.